Aeronautical engineering deals with aircraft design process design, while aerospace engineering is a more modern term that expands the reach of the discipline by including spacecraft design. Its origins can be traced back to the aviation pioneers around the start of 20th century, although the work of Sir George Cavell has recently been dated as being from the last decade of the 18th century. Early knowledge of aeronautical engineering was largely empirical, with some concepts and skills imported from other branches of engineering. The first PhD in engineering, technically applied science and engineering, awarded in the United States, went to Josiah Willard Gibbs at Yale University in 1863. It was also the second PhD awarded in science in the United States. Only a decade after the successful flights by the Wright brothers, there was extensive development of aeronautical engineering through development of military aircraft that were used in World War I. Meanwhile, research to provide fundamental background science continued by combining theoretical physics with experiments. Main branches of engineering. Engineering is a broad discipline that is often broken down into several subdisciplines. Although an engineer will usually be trained in a specific discipline, he or she may become multidisciplined through experience. Engineering is often characterized as having four main branches: chemical engineering, civil engineering, electrical engineering, and mechanical engineering. Chemical engineering. Chemical engineering is a certain type of engineering which deals with the study of operation and design of chemical plants, as well as methods of improving production. Chemical engineers develop economical, commercial processes to convert raw material into useful products. Chemical engineers uses principles of chemistry, physics, mathematics, biology, and economics to efficiently use, produce, design, transport, and transform energy and materials. The work of chemical engineers can range from the utilization of nanotechnology and nanomaterials in the laboratory to large-scale industrial processes that convert chemicals, raw materials, living cells, microorganisms, and energy into useful forms and products. Chemical engineers are involved in many aspects of plant design and operation, including safety and hazard assessments, process design and analysis, modeling, control engineering, chemical reaction engineering, nuclear engineering, biological engineering, construction specification, and operating instructions. Chemical engineers typically hold a degree in chemical engineering or process engineering. Practicing engineers may have professional certification and be accredited members of a professional body. Such bodies include the Institution of Chemical Engineers, ICHEME, or the American Institute of Chemical Engineers, AICAC. A degree in chemical engineering is directly linked with all of the other engineering disciplines to various extents. A 1996 British Journal for the History of Science article cites James F. Tonelli for mentioning an 1839 reference to chemical engineering in relation to the production of sulfuric acid. In the same paper, however, George E. Davis an English consultant, was credited with having coined the term. Davies also tried to found a Society of Chemical Engineering, but instead it was named the Society of Chemical Industry, 1881, with Davies as its first secretary. The History of Science in United States, an encyclopedia, puts the use of the term around 1890. Chemical engineering, describing the use of mechanical equipment in the chemical industry, became common vocabulary in England after 1850. By 1910, the profession chemical engineer was already in common use in Britain and the United States. In 1940s, it became clear that unit operations alone were insufficient in developing chemical reactors. While the predominance of unit operations in chemical engineering courses in Britain and the United States continued until the 1960s, transport phenomena started to experience greater focus. Along with other novel concepts such as process systems engineering, PSE, a second paradigm was defined. Transport phenomena gave an analytical approach to chemical engineering, while PSE focused on its synthetic elements such as control system and process design. Developments in chemical engineering before and after World War II were mainly incited by the petrochemical industry. However, advances in other fields were made as well. Advancements in biochemical engineering in the 1940s, for example, found application in the pharmaceutical industry and allowed for the mass production of various antibiotics, including penicillin and streptomycin. Meanwhile, progress in polymer science in the 1950s paved way for the age of plastics.